Hello friends. In this video we will discuss about green hydrogen, its production, uses and what are the challenges in this fuel technology. Decarbonizing the planet is one of the goals that countries around the world have set for 2050. To achieve this, decarbonizing the production of an element like hydrogen, giving rise to green hydrogen, is one of the keys, as this is currently responsible for more than 2% of total global CO2 emissions. Hydrogen is the simplest and smallest element in the periodic table. No matter how it is produced, it ends up with the same carbon-free molecule. What is green hydrogen? Green hydrogen is defined as hydrogen produced by splitting water into hydrogen and oxygen using renewable electricity. This is a very different pathway compared to both grey and blue. Grey hydrogen is traditionally produced from methane, split with steam into carbon dioxide, the main culprit for climate change, and hydrogen. Grey hydrogen has increasingly been produced also from coal, with significantly higher CO2 emissions per unit of hydrogen produced. So much that is often called brown or black hydrogen instead of grey. Blue hydrogen follows the same process as grey, with the additional technologies necessary to capture the CO2 produced when hydrogen is split from methane and store it for long term. The main point is that capturing large part of the CO2, the climate impact of hydrogen production can be reduced significantly. There are technologies that is methane pyrolysis that hold a promise for high capture rates and effective long-term storage of the CO2 in solid form. Potentially so much better than blue that they deserve their own color in the hydrogen taxonomy rainbow, turquoise hydrogen. However, methane pyrolysis is still at pilot stage. While green hydrogen is rapidly scaling up based on two key technologies, renewable power and electrolysis. Green hydrogen production. Electrolysis is a promising option for carbon-free hydrogen production from renewable and nuclear resources. It is produced by splitting water by electrolysis. This produces only hydrogen and oxygen. We can use the hydrogen and vent the oxygen to the atmosphere with no negative impact. Two electrodes or plates that are made from an inert metal are placed in the water. The electrical power source is connected to these plates. At the cathode part, hydrogen will appear. On the anode side, oxygen will appear. The machine that does this is a hydrogen electrolyzer. We use hydrogen electrolysis to convert electrical energy and store it into the tanks in the form of hydrogen. Uses of green hydrogen. Green hydrogen can help decarbonize sectors such as shipping and transportation, where it can be used as a fuel, as well as in manufacturing industries such as steel and chemicals, where it can constitute an important raw material as well as a fuel. It could replace fossil fuels in power generation and be used to store renewable energy. Green ammonia is produced with a 100% carbon-neutral process. It is produced using hydrogen from water electrolysis that is powered by a renewable energy source, usually wind or solar. Nitrogen is claimed from the air using an air separation unit. Green ammonia is then synthesized by the use of the Haber-Bosch process, which is a clean combustion process and reacts nitrogen and hydrogen together in a high temperature. These conditions create NH3, ammonia, but are powered entirely by clean and renewable energy and emit zero carbon emissions, unlike the standard ammonia production process. Today, ammonia mainly used to produce fertilizers such as urea. But in future it may be put to other uses too, such as carbon-free fuel for transportation and industrial sector. Challenges for commercialization. reduced knowledge on optimum design and return on investment, thus limiting bankability. To meet market demand, organizations will need to scale up and improve their green hydrogen plant designs. However, based on limited market data and low maturity in the space, optimizing plant designs and end-to-end green hydrogen systems can be costly and incredibly complex. Limited specialized workforce and high operational costs. While the rise of green hydrogen will create countless new job opportunities, many individuals still lack the necessary training and skills to support the hydrogen economy. High energy losses. Green hydrogen loses a considerable amount of energy at every point in the supply chain. Green hydrogen off-takers and value. The main challenge is how to monetize green hydrogen. What do you think about this green fuel technology? Send your opinion in comment box. For such informative video, please do like, share and subscribe our channel now.